I realized I was confusing myself with number 8 and making the problem much harder than it needs to be. So I wanted to make a video to make sure that I clarify this for everybody else. So we've already did a little bit of work. We've done partial fractions. So we're trying to find the integral from negative infinity to 0 of negative 1 over q minus 1 plus 1 over q minus 3. Since this is an improper integral, specifically with an infinite bound, we're going to have to introduce a dummy variable, t, so that we can evaluate the limit as t approaches negative infinity from t to 0 of 1 over q minus 3 minus 1 over q minus 1. I flipped the terms because there's a minus sign over here. Now, you should notice that at q is equal to 3, and q is equal to 1, our function is our integrand is not defined. But we don't have to worry about those values for q because we're only integrating from negative infinity to 0. So these values of q don't show up in the area. So that's good. Well, if we want to find the antiderivative of 1 over q minus 3, we know that's the natural log of the absolute value of q minus 3 minus the natural log of the absolute value of q minus 1. Now, because we're integrating from negative infinity to 0, this should be a negative q minus 3 and a negative q minus 1. But I'm going to go through the problem, let's pretend that we didn't know it was the absolute value, and we just said, okay, this is natural log of q minus 3 and natural log of q minus 1. So we can use our log properties, and okay, this is a log minus log, so now there's a ratio in the argument. So this is now the limit as t approaches negative infinity of natural log of q minus 3 divided by q minus 1, evaluated from q is equal to t and q is equal to 0. After we substitute in 0, well, 0 minus 3 is negative 3, 0 minus 1 is negative 1, negative 3 divided by negative 1 is 3. That's just the natural log of 3. And we can substitute t and also get this second term. We know from our log properties that the limit of a sum is the sum of the limits. But since there's no t's in this term, well, that's just natural log of 3, right? The limit as t approaches negative infinity, that's still just natural log of 3. So there's really only this part we have to work through. And I was confusing myself, saying oh, maybe we can raise both sides by e, and then have to natural log afterwards. No, we don't have to do any of that. Okay. First, we should see that, okay, if we substitute in negative infinity, or some arbitrarily large negative number, this would be natural log of, let's say, negative 1,000,000 minus 3 divided by negative 1,000,000 minus 1. The negatives cancel so that the argument is positive. So that's good. We can take the argument of a natural log should be positive. So natural log of some arbitrarily large number divided by an arbitrarily large number. So the argument is an example of infinity over infinity, which is an indeterminate form. So we would have to use L'Hopital's rule to evaluate this limit. Now, this is true for continuous functions, where you can kind of slide the limit inside the argument of natural log. So this would be minus natural log of the limit as t approaches negative infinity of t minus 3 over t minus 1. Alright, this is true with composition of functions, so long as they are nice and continuous. And since we're approaching negative infinity, our function, there's no problems here. The only problem is that t is equal to 1, which we don't have to worry about. So, we can apply L'Hopital's rule. As t approaches negative infinity, the derivative of top is just 1, and the derivative of the numerator is 1. So this is equal to 1. So that means this is natural log of 3 minus the natural log of 1. And we know natural log of 1 is 0. So our integral is equal to natural log of 3. But now let's see what happens if let me zoom out a little bit. Let's say we actually properly did the limit as t approaches negative infinity of the natural log of negative q minus 3 minus natural log of negative q minus 1. Evaluated from q is equal to t and q is equal to 0. So the limit as t approaches negative infinity, well, we could still apply our log rules. This is natural log of negative q minus 3 divided by negative q minus 1. Evaluated from q is equal to t and q is equal to 0. So we see that, right, in this case, we don't have to worry about, well, okay, we see that this is a negative divided by negative, so this is the limit as t approaches negative infinity of natural log of q minus 3 divided by q minus 1. Evaluated from q is equal to t and q is equal to 0. Right, so we can see that it didn't really matter in the end, but in general, you really should keep in mind that, okay, we're integrating from negative infinity to 0, so we should make sure that when we're taking the absolute value of the natural log, we worry about whether it's the positive version or the negative version of the argument.